All right, welcome back. We left off wanting to go over these problems, so hopefully you gave it a try. If not, please do stop it and give it a try and see if you can use the things that we learned, like hydrolysis, reduction, and using thionyl chloride or PBr3 to convert to a more reactive substance like an acid halide, and then do your reactions to whatever derivative you want, just based on what group you're looking for. All right. Take a moment then and pause it, and if you're ready, let's go forward. So with this problem, part A, we've actually solved it before. We had just covered reduction of carboxylic acids back to alcohols. So you could hit this with LAH, which is what we did before, or using the concept now, that we could turn this into a more reactive acid halide, like so, either chloride or bromide. We can then make this into a good leaving group. And based on that, then, we can work backwards. Remember, this maybe comes from this carbonyl group. And so now I've got this ethyl group that I want to get from this chloride, to remove the chloride and somehow make that. So I think you can see how we can bridge the gap and go this way. Okay, so first I would go from here to here, and then I try to go to here, and then try to go to here. See, so the reagents are step 1, so thionyl chloride. Step 2, ethyl magnesium bromide as a Grignard reaction, followed by acid workup or water. And then, so that means this is going to come in, and we're going to displace that chlorine with an ethyl group and regenerate the carbonyl. And then from there, we can do the acetal, cyclic acetal, this way. All right, so this arrow here was when I was working backwards. I'm going to remove that now. Okay, so that is my step 4. All right, so that's another way to do it now that we know this reaction. Okay, so quite efficient. Now this next one here, notice that we can't reduce this with LAH because then we'll end up with this carbonyl gone, but we still have this amine group, but that's not what we want in the end, and it's going to be hard to introduce a double bond there. So working backwards then, you probably know that this comes from a carbonyl that maybe looks like this, and an amine, a methylamine, because we have a methyl group on there. Okay, so NH2CH3. These two have to couple to make this amine. All right, to do that, we use a little bit of catalytic acid as well to activate this group here. And so now my question is, how do I get from here to this aldehyde? So there's a couple of things you could do. One is you could start from this amide, and you can hydrolyze it to a carboxylic acid. So I want to make this carboxylic acid. And then if there's a way to reduce the carboxylic acid, we probably need to reduce it all the way down to the alcohol first, and then oxidize it to the aldehyde using PCC. Okay, so I'm going to reduce it, and then this. Okay, so it's a lot of steps. Let's fill in the reagents we need. First step is, oh shoot, I should have just put the OH here. Okay, so we start with the starting material here. We need water and H+ to make hydrolysis of this amide, makes a carboxylic acid, OH coming from water. And then we reduce it, LAH, excess. Okay, followed by water workup or dilute acid. And then step 3, we need catalytic acid with this primary amine to make the amine. So what are the new concepts here? It's this reduction step right here. Another thing you could do alternatively is make the acid halide. So you could turn this, use Sokol, turn this thionyl chloride, turn this into an acid halide, and then reduce it, maybe use a hydride reagent, but then this would reduce down to an alcohol, and then you'd have to oxidize it again anyway. Oh, and I'm so sorry, I forgot. And then after this step, you'll need to oxidize it to an aldehyde. So step 4 will be PCC. And then step 5 will be the amine and catalytic acid to make your imine. All right. So the new concept here was this reduction step here. You could figure out a way to use thionyl chloride, and from here you could make the acid halide, and then you could treat this with dibol H to get that. So that would be an alternative route. So instead of reduction, you could do step 2 SOCl2, step 3 dibol H. That provides one equivalent of hydride to keep it at the aldehyde instead of all the way down to the alcohol. So it's an alternative way you could also do this. All right, for part C here, we're looking for a way to have a nitrogen here. This one looks really tricky, doesn't it? I might think about trying to get rid of these carbons actually, and maybe I'll just have to have this group come back on somehow later. Okay, now I know from a carboxylic acid going to an amide, I can work backwards a little bit. So I know that from here, perhaps I had this acid chloride, and then I could add this amine to it and replace that group. Okay, so that's one idea. And maybe this came from a carboxylic acid then, because I can do SOCl2. How do I get this oxygen here, though, if I have these carbon groups? Well, I think you remember the Baeyer-Villiger reaction. If not, go ahead and review it. Baeyer-Villiger inserts an oxygen in the most substituted R group here. Okay, so that's Baeyer-Villiger oxidation, and that's an ester. So if I could get the ester to a carboxylic acid, make the acid chloride, and then make the amide. Seems like a lot of steps though, right? But that's one way to do it. So Baeyer-Villiger oxidation, I need oxidizing agent like peroxy acid. So RCO3H, okay? Or you could write peracid if you like, or you could use MCPBA, which is a type of peroxy acid. All right, so there's my Baeyer-Villiger reaction. Now I want hydrolysis of the ester. I want to get rid of this part. So I need catalytic acid and H2O for hydrolysis. That's how you get an OH group. Then I use thionyl chloride. Okay, so step 1, step 2, step 3. And finally, step 4 is I don't even need catalytic acid. This is going to be pretty reactive because I'm using an acid chloride. It's going to be reactive enough. So I just need to find the correct amine, which is dimethylamine. And then I've got my amide. Okay? All right, and the last one is an ester. And I want to turn it into maybe an aldehyde and then use this thiol protecting group or acetal, okay? So thioacetal. So working backwards again, from here you could probably easily picture that you need something like this aldehyde. And you're going to apply a cyclic thiol, or sorry, this dithiol group, okay, ethylene dithiol. And from there, okay, how do I get an ester to an aldehyde? Well, I just need an equivalent of hydride, right? Because then that will give me my aldehyde. But that aldehyde usually is sensitive to further reduction if I just use any hydride reagent. I have to use the hydride reagent that it can only give me one equivalent of this reducing agent. So I'm going to use dibol H. Or the book has this version, LiAl, 3 hydrides replaced, and 1 hydride available for reaction. So that is my first reagent. Get the aldehyde and then thioacetal. Hopefully you could follow these. If you had trouble with these though, please do revisit this. This will help you learn your reactions. So do it several times until you feel comfortable that you know these reactions and why you're doing them in this particular order. Work it forward, work it backwards.